Hey class, welcome back to our silent science subject, and today we're getting back into our energy transfer and transformation book, and we're getting into chapter 6. So like I said at the beginning of the videos, if you haven't watched the previous chapters 1 through 5, please go back and watch those because those are the foundation to chapter 6, and chapter 6 probably not make very much sense if you don't understand the previous things. In chapter 5, we talked about how energy is involved in collisions, how the greater the speed, the greater the energy, and the greater the change. So as cars collide, if they're going faster, and because they weigh more, they cause and have more energy, and they can cause collisions, which cause motion changes or shape changes. Just like if you were to drop an egg on the floor, it changes shape and it splats. But if you drop a basketball on the floor, it doesn't change shape, it just changes maybe the direction or the speed of the way it's moving. So let's get into chapter 6. This is our second to last chapter. So those that are on track, good job, you're doing great, keep it up. Those that are trying to get caught up, you're doing awesome. Just remember to complete your big question discussion post. And I don't even, this chapter has some vocabulary words. I think there's couple chapters or a chapter that doesn't have any vocabulary words, or maybe just one. But remember to complete the chapter vocabulary assignment if the chapter does have a vocabulary assignment. Remember to use the definitions from the book for your chapter vocabulary, and then with your big question discussion post, please do not copy and paste an answer. Please use your own words, and that will help you continue to learn and improve as a student and becoming better at critically thinking, which will help you out in school as well in your everyday life. So let's start reading and call attention to the big question. How do energy transformations help people? Okay, so this chapter is titled as a question, how can energy transformations solve problems? We've talked about how energy can cause changes, and how energy can transfer from place to place or from object to object. How are these transformations helpful to us as people? So that's what we're going to look and learn about during this chapter. Let's start reading and follow along with me. Imagine living in a time before toasters. You want to toast a piece of bread? You hold the bread over a fire, but it burns too quickly. Now you have burnt bread, which is not fun. This is a problem. Suppose you need to meet a friend in the morning, but alarm clocks have not been invented yet. You are late and your friend leaves without you. That is also a problem. We're starting to see some reasons and how energy is used and how energy transfer can help us, right? Engineers are people who use science and technology to make things that people want or need. To an engineer, anything that people want or need presents a problem to be solved. All kinds of problems can be solved through the design of new devices. Toasters and alarm clocks are devices that help people. Many such devices are designed to make use of energy transfers and transformations. Right? So we're learning that the things that we use in everyday life are problems that were solved by engineers and people, and they're using energy and energy transfers and transformations to help solve these problems, such as a toaster to heat the bread so that you can, put jam or butter on it and make some, a good breakfast or snack. All right, now let's read this, and I want to call on Bobby. What does the title of this say? Good job. Solving problems requires understanding energy. In finding solutions to problems, engineers consider the properties of energy. They know that energy can transfer or move from place to place, what we were just talking about in the previous chapters. As a bowling ball collides with bowling pins, some of the ball's energy of motion is transferred to the pins. Your score goes up. Problem solved. Engineers also know, as we do, that energy can transform or convert from one form to another. Here's our first vocabulary. What does this definition say for convert? To change form. So energy can change form from one form to another, or convert from one form to another. So when a bowling ball collides with pins, some of its energy of motion converts to sound energy as the surrounding air vibrates, and also the pins being knocked down. Such conversions occur when energy changes from one form to another. So we learned about how converting is to change form. Now conversion is the process of being converted or changing form. So people use what they know about energy changes to design and build devices that make use of these energy transformations. Okay, so energy being converted from one form to another, the energy conversion, which is causing these energy transformations, which is, the definition says, the change of one form of energy to another form of energy, right? Energy conversion. These devices can make life easier, more productive, and even just more fun. Okay, so here's our problem. Engineers find a problem or recognize a problem. You need to know what time it is. The solution: mechanical clocks use springs to store energy. They transform stored energy to motion energy. The moving clock hands show people the time of day. And we talked about this either in chapter 2 or 3 about how they have the pendulum and the clock, and that has energy, and that's making the gears move, so we can know how much time has passed: a second, a minute, an hour. All right, our next section. Read this with me, Dante. Transforming motion energy can help solve problems. Thanks. People need electrical energy to power all sorts of devices. Our phones, computers right now especially, we're all online. But where does this electrical energy come from? Most of the electricity we use in our homes comes from the transformation of motion energy to electrical energy, which we talked about in chapter 4. How either it could be a windmill, it could be a reservoir and a dam, using the motion energy from the water to move the turbines to get the energy into a generator to transfer through power lines to our house. In 1831, a scientist named Michael Faraday discovered that moving magnets past copper wires in certain ways produce a flow of electrical energy through the wires. He discovered a way of transforming motion energy to electrical energy. So, magnets past copper wires in certain ways could produce a flow of energy. So many energy engineers have used Faraday's discovery to build generators, rotating devices that convert motion to electricity. Hydroelectric dams and the turbines of wind farms use the movement of water and wind to rotate generators. We talked about this in chapter 4 and 2 or 3 with the wind farms. So the spinning motion in the generators is converted to electrical energy. So as the coiled copper wire is moving, the motion energy from wind, water, or an engine can spin the rotator of a generator, and this is causing electricity. So here's our problem. The engineer realizes we have a problem. People need electricity to power many of the devices they use. The solution: generators convert motion energy from spinning parts to electrical energy. Okay, now let's read this. Jasmine. Transforming stored energy can help solve problems. The transforming stored energy can help solve problems. Batteries provide electricity as well, right? As well as the moving generators. Batteries are made of chemicals that have stored energy. The stored energy in a battery transforms to electrical energy. In turn, the electrical energy can be transformed in useful ways by many other devices. We have rechargeable batteries in our phones. So the energy is used up, and then we plug it back into the wall, and then the electricity recharges and stores the energy so we can reuse that phone. Some batteries die or lose all of their stored energy, have been transformed to electrical energy. Other batteries can be recharged. Rechargeable batteries can convert electricity from a wall socket to stored chemical energy for later use. Rechargeable batteries are especially useful for small portable devices like our phones, right? A cell phone, for example, converts stored energy in its battery to electrical energy. Electrical energy from the battery transforms to sound energy when the phone rings and the voices come from over the speaker, light energy when the screen displays pictures or videos, and motion energy when the phone is set to vibrate for notifications. Okay, so here's a problem. People want to be connected to others wherever they go. Solution: smartphones with rechargeable batteries store electricity and transform it to sound, light, and motion. Alrighty. Transforming light energy can help solve problems. Let's read this together, Zayden. Read the first two sentences with me. Solar cells are made of material that transforms sunlight to electrical energy. And one more sentence. The transformation of energy from sunlight to electrical energy also happens on a very large scale. So now we're going to learn how we can capture the energy from the sun using these solar panels. So solar panels convert sunlight to electrical energy during the day. Some of that electrical energy can be stored in batteries to power useful devices at night when the sun is not out, or maybe if the sun is blocked by clouds. We got the solar pad that can charge this phone battery in a small and portable. Bigger solar panels can convert more sunlight to electrical energy, provide electricity for a home that doesn't have power, electricity generated by a power plant. So enough solar panels in a sunny region can provide all the electricity needed by an entire community. It doesn't have to be hot to be sunny. You don't even have to be on Earth for it to be sunny either. Solar panels solve the problem of how to get the electricity needed to operate the International Space Station. Pretty wild. All right, I think this is, our last section. So you guys are doing good. Stay with me. One more section and we'll be done for today's lesson. Energy design solves problems. So all the devices that you have, that we have and that we just read about transform energy. They have something else in common too. They were developed using a process called engineering design. Now let's pause and read this definition. A process used to develop a solution to a problem. So engineering design is used by scientists and engineers to develop solutions to problems. The process starts with identifying a problem to be solved, and that's kind of what we were reading about in those little captions throughout this chapter. We read a problem, and then we read how it was solved. Teams of scientists and engineers determine a want or need that the design is going to meet, and what the design is going to meet. Then they judge possible solutions by how practical they are and how well they solve the problem. For example, electric cars must have rechargeable batteries that store a lot more electrical energy than a phone battery. If even the car could work on a phone battery, it wouldn't probably last very long because that car is going to use up a lot of energy. So an electric car battery must store enough energy but not be too heavy or too expensive. Designers have to consider things like cost and weight to solve problems without creating new ones. And that is it for chapter 6. You guys are awesome. Thanks for reading and following along and learning with me. So how do energy transformations help people? Well, a few examples were the toaster, the transfer of electricity to heat the bread so it's nice, brown, and crispy and not burnt is very nice. The ability to use stored energy for our phones so that our phones can use that energy in light, motion, or sound, right? When we talk to people or hear it vibrating, the energy transformation of sunlight to solar power to, give the home electricity so it can, do the things it needs to. A clock using that energy to tell us what time. Those are some transformations that help us as people. That should help you with your big question. That is it for chapter 6. We have one more chapter, chapter 7, and I will see you then.